This is the chapter 20 worksheet here, so we're going to go over this relatively quickly, do some of the problems here. What is oxidation? Alright, we should know that. Oxidation is the loss of electrons, and reduction would be the opposite. That's the gain of electrons by an atom in a compound or an ion, whatever it is. A reducing agent oxidizes something else. No, a reducing agent reduces something else, right? But it gets oxidized. Excuse me. So a reducing agent gets oxidized. And what's the best one to getting oxidized? That's lithium solid on the table. I don't have the table here. What is an oxidizing agent? An oxidizing agent oxidizes something else and it gets reduced, and the best one at that is fluorine. So that's the top of your reduction potential table. The bottom is your reducing agents that get oxidized. All right, identify those elements that go changes in oxidation number and indicate the magnitude of the change in case and if the element was oxidized or reduced. So when we're doing this, MnO4, that's a minus right there. It's kind of hard to see sometimes. This one you have to know your oxidation numbers of certain things. Oxygens, in our case, always -2. 4 oxygens would be a total of -8. So then I need a -1 overall charge. So my manganese side has to be +7. +7 -8 is -1. And there's only one manganese, so manganese is +7 in that case. S2- is an ion, and ions have their own charge. So the charge here is just 2-, and oxygen is -2. Here in water, hydrogen needs to be +2 to balance it out because it's neutral, so each hydrogen is +1. There's 2 of them. Here, sulfur, a element by itself, has a 0. 2 oxygens, oxygen's -2, that's -4. Manganese then is a +4 to balance that out. And OH-, oxygen's -2, hydrogen's +1, that gives you your overall -1. So let's look at what changed here. Manganese went from +7 to +4, so it gained electrons, right? Its oxidation number got reduced, so it's reduced. And then what did sulfur? Sulfur went from 2- to 0, so its oxidation number went up. It got oxidized. The other ones all stayed the same. Here, this one, Hg2+, 2+. Hydrogen is always +1 with non-metals. 4 hydrogens is +4. Nitrogen here is then needs to be -4. 2 nitrogens then at -4, so each one would be -2. Again, if you wanted to do that formulaically, which I left out last time, right? If you have N2H4, that's 2 N's plus 4 H's equals the overall charge. This one happens to be neutral, so it's 0. And we know that hydrogen is going to be +1. So that's a 0, equals 0, I mean. 2N equals -4, so N equals -2. It works out the same way. Mercury here is an element, so its charge is 0. Oxidation number 0, excuse me. So is nitrogen. Nitrogen's an element there, 0. Hydrogen here, +. So what are we looking at here? We have our mercury goes from 2+ to 0, so it got reduced in oxidation number, means it gains electrons, and our nitrogen here went from -2 or 2-, whatever, doesn't matter, to 0, so it got oxidized. Alright, balance the following equation and identify. So here we're going to balance the redox reaction here. Alright, so you take your two half reactions, NO2 minus becomes NO3 minus. So I have 3 oxygens on the right hand side. I need to balance, my first step is balance my oxygens with water. So I have an H2O on the left there. That gives me 3 oxygens, 3 oxygens. Now on the right hand side I have two hydrogens on the left. I need 2 on the right, so I balance those with H pluses. So there's a -1 on here, -1 here, and there's a +2H here. So now I have to have the charges equal on both sides. So there's a -1 on the left, and over here right now I'm a +1, so I need to bring it down with electrons. So I add 2 electrons to that side. Alright, and now I'm balanced. My charges are balanced, all my elements are balanced, I have 2 electrons. The other side, chromium, Cr2O7, 2 minus. That's never going to work. Oh, I'll leave some room here. Becomes Cr3 plus. My bad. First thing to do is balance actually all other elements that aren't hydrogen or oxygen. In the first case, that didn't matter. Here, there's 2 Crs on the left, and then we need 2 on the right. Now I balance my oxygens with water, so I need 7 waters over here to balance out the 7 oxygens there. That gives me 14 H's, so it's 14H plus. And now we add them up. This is +14 and -2, so that's a +12 on the left. On the right here I have a +6. So I need to bring the higher side down by 6 to match it, so I get 6 electrons here. Alright, now I need my electrons. They should be on the opposite sides of the reaction, which they are. Here they are a product, here they are a reactant. That's good. And I need them to be equal. So I have to multiply this half reaction by 3 to get 6 electrons, which matches this one. So I'm going to write that over here, where I got 3 waters plus 3, NO2s. Gives me 3 NO3 plus 6H plus 6 electrons. And now my electrons have to cancel out, which they do. And then you subtract things on opposite sides of the equation, right? It's by the lower amount. So here I have 3 waters on the left, 7 on the right, so I'm -3 H2O. So those go away. Here I subtract 3 H2O, and I'm left with 4. Over here we have 6H plus and 14H plus on the other side, so it's -6H plus. -6H plus gives me 8H plus left. So now I add them all together, and I get Cr2O7 2 minus plus 3NO2 plus 8H plus gives me 2Cr3 plus 3NO3 minus plus 4 waters. Got a little hectic up there. Alright, so that's how you balance a half reaction there, a redox reaction. I'll do one more example here. Let's do this bottom one. BrO3 minus and N2H4 become Br minus and N2. So I have my BrO3 minus becomes Br minus. My bromines are balanced, so I need to balance my oxygens with water, 3H2O. On the left-hand side, then, I need 6H plus. Alright, and now I have to balance my charges. I have a -1 on the right, and a +5 over here from these guys, 6 and -1. So that gives me 5 electrons. I need to bring that down with. Other side, N2H4, I did this again, becomes N2. So there's 2 N's on both sides. There are no oxygens here. So now I just go straight to the hydrogens, 8H plus And on this side is neutral. This side has 8H plus, so it gets 8 electrons. That's a lot. That's a weird one. So now I need to, the lowest common factor here is 40. So I have to multiply this side by 8. I'm not going to go this high on the other one. And this side by 5. So you would get 40 electrons. Did I do that right? Plus 48 protons plus 8 Bro3 minus gives me 8 Br minus plus 24 waters. And on this side, I get 5N2H4 becomes 5N2 plus 40H plus 40E minus. So when I add them together, I'm going to run out of space. N2H4, 5. I'm just rewriting. I haven't done anything here. Alright, so my electrons cancel out. Good. I subtract 40H plus on this side and 40 from here, which leaves me with 8H pluses. The water doesn't cancel out because there was only one on, it was only on one side. And what's that leave me with? It leaves me with 5N2H4. Oh, did I do this wrong? Yep, I did it wrong. Dang. Alright, I apologize for that. I did it wrong right over here because it's good. This is a good learning lesson here. There's only 4 H's over here. So I don't know why I made 8. That would cause a problem. I can't edit this, so I'm just going to keep going. So I would get 4H plus and 4 electrons. That makes more sense. Thought that was a little bit high before. So now when I need to balance 4, 5. Oh, so then no, that's right. Answer key's wrong. No, it's wrong. And this is 6. Yeah, I messed this one up. Sorry. Anyway, so now it's 4 and 6. That's 12. So I multiply this side by 2 and this side by 3. I didn't put any with this complicated of a thing on here, but it shouldn't have been that complicated. Anyway, that's 12 electrons plus 12 H pluses plus 2 Bro3s minuses, still there, gives me 2 Br minus plus 6 H2O. And I'm going to multiply out this other side and just write it down over here for this time. 3N2H4 gives me 3N2 plus 12H plus 12 electrons. Yeah, that looks a lot better. 40 was a lot. So I can cancel out my electrons, my H pluses. There's 12 on the right and 12 on the left, so they actually cancel out. And then everything else is left over. And I get 2 Bro3 minus plus 3N2H4 gives me 2 Br minus plus 6H2O plus 3N2. Sorry for the confusion there. It happens to everybody. Alright. Right. Voltaic cell, like the one in figure 20.5. So over the voltaic cell, one half cell consists of aluminum strip in aluminum solution. The other has nickel in a nickel solution. There's your overall reaction. What is being oxidized and what is being reduced. So my aluminum is going from 0 to 3 plus, so it's getting oxidized. The nickel goes from 2 plus to 0, so it gets reduced. Write the half reactions that occur in the two cells. This isn't asking you to balance it. It's just writing aluminum solid is becoming aluminum 3 plus, and nickel ion is becoming nickel solid. Which is the anode and which is the cathode? The anode is what gets oxidized, so that's the aluminum. The cathode gets reduced, that's the nickel. Indicate the signs. The anode is always negative. The cathode is positive. Do the electrons flow from the aluminum to the nickel or from the nickel to the aluminum? It goes from the anode to the cathode, so it's aluminum to nickel. And which directions do the cations and anions migrate? Anions go toward the anode. Cations go toward the cathode. All right, that was a fun one. Here, standard reduction potentials. I don't think I really need to go over this. There is a table there. You need to know the reaction that the reduction of the cell, the actual thing that's generating electricity, it's E cathode minus E anode. The cathode is always the one higher up on the table. Right, so it has the bigger, the higher value. All right, so that's all you would do there. Which use the data in Appendix C to choose the stronger oxidizing agent. Oxidizing agent, don't push that. Actually, you can push that. Oxidizing agent equals gets reduced. So the stronger oxidizing agent would be higher on the table.
Dad, I'm walking the.
I see what you're doing up there. All right, here determining which of the following substances is likely to serve as an oxidizing, reducing, or reducing agent. So you just look in the table. If it's high up on the table, it's a reducing agent. If it's higher on the table, it's an oxidizing agent. And a reducing agent would be lower on the table. What is the product of both half reactions in a lead-acid battery? It's PbSO4. So both reactions, the oxidation and reduction reaction, give you the same product. Why can it be recharged? Because all substances involved are solids. So they're always in contact with each other, so you can always add electricity and reverse the reaction. That's why it works. That's the beauty. Lithium batteries, why are they, what makes them useful and why are those so useful? All right, lithium is light and it has a high energy density. Right, so you can pack a lot of lithium in there. You can also get a high voltage because it's on the bottom of the table. It's the easiest to oxidize, so you give the biggest difference there. When discharging the lithium plus battery, in which direction do the lithium ions flow? The lithium ions go from the anode to the cathode. All right.